Thank you. Thanks, Amy. And good morning, everybody. And fantastic. Well done on taking the time to understand a bit more about this big topic of climate change, and also thinking about how does it affect Gippsland and what can we do about it. So thanks, Hayley, for your great introduction there. So I work with Agriculture Victoria. So we do a lot of work on climate. We've got a team that I manage, which is really about managing climate risk. So we do a lot of work with farmers. Over 120 forums a year we'll speak at, talking about local rainfall history, what's been the key drivers of each sort of region's wetter and dry years, but also what's been changing recently as well. We also have lots of work on forecasts and understanding seasonal forecasts, things like soil moisture probes. There's a lot of work happening at the minute where soil moisture probes are buried up to 1 metre deep under the paddock, and so that's giving really good monitoring to know how much moisture and water do we have in the soil, which is really helping with farm decisions. And I know that there's quite a few that are being planned for down in Gippsland as well. So really exciting things, all of these technologies that are helping us manage this better. We've also done a few sort of climate information things, which we'll share a little bit later, things like the climate dog animations, which are just sort of summaries of the science of climate. So I'm just going to start with this particular image. So if you see down on the bottom left, this is a map of Australia, and it's the 3 years of rainfall from 2017 to the end of last year, 2019. And you can see these red colours here. The dark red is where it's the driest 3 years on record. So, and if we just have a look at from a Victorian point of view, you can sort of see there that there's a big patch of Gippsland that's had its driest 3-year period on record. That was up to from January 2017 to December 2019, end of last year. So we'll talk a little bit about, there's been a lot of variability in Gippsland, but is there anything different now? What might have been behind that? So we'll have a bit of a discussion about that. Now, one of the first things to talk about rainfall is just really back to the original concept. If you were given the task of how to make rainfall, there's two critical ingredients that you have to make rainfall. So I just want you to have a think about what would be those two key ingredients. If you were given the job to go out and make rainfall, what would you be needing? And often ask this, and we have a lot of good discussion, but one of the first things is people say, well, you do need to have some moisture. You've actually got to have moisture in the air, because if you've got really dry air, you can't make it rain. So first of all, the first ingredient you have to have is moisture in the air. But if all we had was moisture in the air, it would just be really humid. Sometimes if you've ever gone to Queensland, or if it's a really sort of muggy weather, if you just had moisture in the air, it would be humid. So something else has to happen to make that moisture fall out. And that's basically where we get a cool trigger, such as cold fronts that come through. But basically what happens, if you lift up the moist air, as we go up in the atmosphere, it gets cooler. And when that moisture's in the air, if it cools down pretty quickly, then the moisture falls out as droplets, and that's how we get rain. So it's pretty important to think about that when it comes to the Gippsland. And I'll just talk about this picture up the top left, where you can see here how rain's made. And here's a mountain range. And when you have moisture that's coming in, and as it gets lifted up, as it hits the mountain, as it goes up, it gets colder, the air gets colder, and then out it falls as rain. And so we see that happen a lot in Gippsland, and often sometimes weather events, depending on which direction they come from, they can decide which side of the mountain range gets the most rain. What's also interesting, you'll notice on this side of the mountain that when air is coming down, so air's cooler up higher, when air is coming down, it actually starts to get warmer again. And when air gets warmer, it can hold more moisture. And that's often why you have a rain shadow effect on the other side of a mountain to a rain event. So that's pretty important about, that sort of disturbance that helps to make moisture fall out where it does. And this image up on the top right is just showing an example of a cold front, because sometimes cold fronts sweep through parts of Victoria, and they can often bring rain. And so if you can imagine here, you're standing on this side and it's a warm day, and here's the cold front. You can see the cold air coming through. And what the cold air does, it's a bit of a wedge, and it forces the air up. And if there's any moisture in this air, then as that air is getting forced up, that's why we get cold and rain during a cold front. So they're both really important parts of how it is rain made in Gippsland. And you can sort of see there's a lot of mountains and things which affect rain depending on which direction weather events come from for Gippsland. And so we have a lot of weather that comes from the west. And when we talk about the really dry, that dry period for the previous 3 years, we had a lot of westerly winds, which meant that, the weather was coming from this way. The air would be lifted up, so West Gippsland would be okay. And West Gippsland's been pretty green for the last 3 years. But when you look at sort of central and east Gippsland, if a lot of your rain events are coming from that direction, then this area is in the rain shadow. So often to get wetter years in East Gippsland, you need moisture coming in from this way, from a different direction. And as it comes in this way, it gets lifted up on the mountain, then we get lots of good rain. So sometimes it's just to do with weather patterns and which direction it comes to, which really makes why Gippsland's a fascinating place for and all of the different climate zones that you have there locally. Here's a map, a satellite image, just showing that across the world, where most of the moisture starts from. So you can see these colours here. This is just showing the total amount of water that sits in the air. So total precipitable water, which means water that can fall out as rain. And you can see here, these sort of colours are down to where there's 60 or more kilograms of water per cubic metre of air. So it's amazing how much moisture can fit into the air. So you can see most of the moisture starts out along the tropics, the equator, which is where the planet is at its hottest and the ocean's warmest. So it's where most of the moisture starts. And what happens when we look at down in Southeast Australia, where we live, some years there's more moisture feeding down into our weather patterns than other years. There can be all of the moisture is sitting over somewhere else. So that's why with each year can be a little bit different. And we'll talk a bit about that, because it's a key part of just variability. And this is a particular picture that I really like. You can sort of see here, it's a vision of the southern hemisphere. There's Antarctica, that big chunk of ice in the middle. But you can see that Australia there and southern Australia and where we live. You can see South America over there. But you'll notice some of the key things that drive our weather and seasons in Gippsland. Here you notice around the Southern Ocean all of these cold fronts that are queued up, and basically this incredibly strong winds whiz around the Southern Ocean. They're called the Roaring 40s, and that's like a conveyor belt and carries all of these cold fronts through, and they swish their tails across southern Australia. So they're a really important trigger for our rainfall events. And some years those cold fronts can be sitting a lot further south, and often we get less chance for rain when that happens. So it's a really important climate driver. It's called the Southern Annular Mode, and it's also a climate dog tells its story of what it does. Also, we have out in the Pacific Ocean, it's our world's largest ocean, and it's a big driver of the globe's weather. And some years it's sending us more moisture, in a La Nina years where it's sending us a lot more moisture to Australia. And then other years like an El Nino year where it's sending more moisture out into South America, it's heading the wrong way. So we know that it can have an influence of wetter and drier years. And then there's another one up here called the Indian Ocean Dipole, which can be really important. Some years it can send lots of moisture in these sort of northwest cloud bands that feed into our weather patterns. And when that moisture hits this cold air from the cold fronts, it all falls out as rain. So it's really interesting that we've got all of these key elements to what makes our wetter and dry years. And then there's one here, you see STR there, we call it Ridgey, or the subtropical ridge. It's sort of a band of where the high pressure patterns happen to sit. So farmers watch these things on the weather map and are looking at them to see what sort of a mood are they in? Are they in a helpful mood from a rain point of view, or are they actually starting to chase rainfall away? And there's a particular website we've set up here. This is just an example of Leongatha's rainfall for the last 120 years. But what we've done on this particular site was we've coloured in the individual years where one of these particular climate drivers was having an active phase. And what you'll notice is sometimes when both of those oceans, like the Indian Ocean and there's an El Nino in the Pacific, if both of them decide that they're not really in a mood to send us much moisture for our part of the world, you can see there that for Leongatha, some of those bigger dry years and droughts that I've just highlighted there with the black arrows, they were years when there was a combination of an El Nino in the Pacific, which wasn't being helpful for moisture, and an Indian Ocean dipole, which was meaning it was being drier too. So it's really good to show that this is all part of variability that we've known about. But is there anything happening now that's different due to just variability? Because we work with a lot of farmers and say, listen, we've had a lot of variability in our district with our long-term rainfall records. So what's different nowadays? And I guess this is one way of showing it. On the left here, these are two posters we've got, and we can certainly send you posters if you'd like them at your school. It just shows, this is on the left here, it's rainfall history, and starting in 1910, and it's each year going through to 1919 and then 1920. And it goes through the whole century. And basically the bluer colours are years where it was wetter than average, and the red areas are where there was years where it was a lot drier than average. So if you can see there, there's been lots of variability, and you can see sometimes where there were a few wet years joined together. And so a lot of variability, and there was 2019 last year, quite a lot of red. But if you notice over on the right, this is the maximum temperature story. So starting at 1910 and again crossed to 1919, each decade as it went through. Now the blue colours are cooler than average years, and then the yellow and the orange is warmer than average or warmest on record. And so just have a bit of a look at that and see, do you notice any difference there between those two posters? Because what we can sort of see that, yes, there is a lot of climate variability, which we'll continue to have to get, but also we've got this really strong warming trend you can see here. So let us know if you'd like a copy of some of those posters. So the next question is, we often get asked is, so why is our climate becoming warmer? And Hayley gave a great example of that. I like to tell a story of greenhouse gases and when they were first discovered, which was back in the 1850s. So that's when the gold rush was on in Victoria. But luckily there were some important scientists who were at the time really trying to understand how energy worked in our atmosphere. And at the same time, there was a scientist called John Tyndall over in the United Kingdom, but also recently discovering there was a scientist, Eunice Foote, who was over in America, and both of them were working on this at the same time and came up with this theory of greenhouse gases. And how it happened is they knew that when we get sunlight during the day, the sun beats down and warms the land surface, and the land absorbs that heat. But when the sun sets at night, that heat that's been absorbed during the day just radiates back out to space. And so these sort of physicists, they'd worked out that, you know what, when we wake up in the morning, it actually should be almost 30 degrees cooler than what it is. If all of that heat escaped at night, it should be 30 degrees cooler. So they were saying there's something in the atmosphere that's not letting all of that heat escape every night. So what is it? So they did the experiment where they got the gases from our atmosphere and passed heat radiation through the gas, and to try and work out which one of these gases is capturing heat and keeping it trapped. And so most of the atmosphere is nitrogen gas and oxygen. So they just had they took what they called the impurities, the other gases, and put them aside, and they tested nitrogen and oxygen, and they passed the heat and it went straight through them. So they said, well, if our atmosphere was just nitrogen and oxygen gas, then we would freeze every night. So what's in these impurities? So they got these gases and then they tested them, past the heat radiation, and these gases absorbed the heat. They wouldn't let the heat through. And that's where they discovered the greenhouse gases, which is, carbon dioxide, methane, water vapor, nitrous oxide, and a whole lot of those sort of gases were discovered back then. So the simple theory was that if we put more of those gases in the atmosphere, then they would just start trapping more heat. And a key thing of what some of the NASA and the observed via satellites is that over time, what they've watched is as we've been getting warmer in the inner atmosphere, the outer atmosphere, which is called our stratosphere, it's actually been getting cooler. So we're still getting this similar energy from the sun. It's just that we're changing the ratio of what's escaping. So, and imagine the analogy of a car, two cars parked on a sunny day. Imagine they're parked in the sunny day. Both dashboards of the cars are getting plenty of energy from the sun, and the dashboards warm up and start radiating heat. But imagine if one of those cars has the windows up and the other car has the windows wound down. What do you think would be different between those two cars at the end of the day? So the one with the car with the windows wound up, it's actually the dashboard generating the heat is not able to escape, and so that car gets quite hot inside. And on the car where the windows are open, then that heat can escape. So largely the greenhouse gas story is we're slowly winding up the windows. And one of the key things, as Haley explained, is why we're trying to make sure we slow down over the next few decades and really make sure we don't add any more. And that's why there's a lot of discussion around aiming for carbon neutral targets by the year 2050. So there's a lot of work to do in the next 30 years to get there. So some of these changes that we're seeing in our region, so these are temperature, maximum temperatures for southeastern Australia, and that's just showing the season for summer, autumn, winter and spring. And we can see that there's a lot of variability from one year to the next, but you can just see, in the last 10 years that most of them have been warmer. Also, what's interesting is that as the planet warms, 90% of the extra heat that's absorbed goes into the oceans, but it doesn't all go into the oceans equally. And what we'll notice is just off the coast of East Gippsland is in the Tasman Sea is one of the fastest warming areas of ocean around. And that's certainly something that's been happening for a decade or two now. And what's interesting is fishermen and other marine scientists have been noticing how with that warmer water down off the east coast there and it heading further south, with it has been coming some of the more warm water fish such as swordfish and heading further south and they're catching them down in Tassie. Also, that's been having an impact on some of our seaweed species that really, and the kelp that really like cold water. Other changes in our region are things like the pressure pattern. So this area of southern Australia, and this is just showing the pressure over southern Australia since 1950. And you can see that it varies from year to year. But one of the things with global warming is as the temperature gets warmer, there's processes in the atmosphere, which means that for southern Australia, the pressure pattern is stronger than it has been in the past. So if we repeated the last 100 years of weather patterns, but with a higher pressure, you know what happens? We get, it'll squeeze out the rain a bit more often. And what that means, we're starting to see in some catchments around Victoria where some of the catchments, this is just from the Buchan River from 1950, you can just see that, there's less of those sort of wetter years. So you can just see that in some of our catchments where they're not running off as much runoff as they used to. So that means we've got to adapt to how can we be more efficient with water. This is just Victoria's updated its climate change modelling and projections, and there was a big report released just last year, and there's a website there you can go and look at it. But it sort of shows, this is for Australia and the last 100 years. The black line here is the actual observed temperatures for Australia. And what's interesting, these two bands here, this is sort of what's projected and the direction for future for temperatures. But this band here is what happens with all the climate models. If they keep greenhouse gases at the same level as they were in 1950, then that's sort of the climate we should have got. But you can see here we're at the early stages of climate change, and hence why there's a lot of work to try and reduce emissions from here on. So we know there's lots of work happening, and agriculture, while climate change is an issue for agriculture, we also know that agriculture and food production happens in many different climate zones across Australia and across the world. So we know that we can produce food in lots of different climate zones. Our challenge is just how do we do that when the system you're used to and the weather that you're used to in a particular region starts to change. Then that means we have to change to actually be able to manage that and to either be able to farm with less water or improve our soils so that they absorb more moisture and that sort of thing. So there's lots of exciting stuff that's happening on farms right across Victoria, and lots happening in Gippsland too. And I guess part of the key thing is that this sort of adaptation, it's all about people working together. So, which is terrific why you've got today, and understanding who's doing what and some of the farmers you'll be speaking to and what they can do. So, and there's lots of exciting jobs in agriculture and in you know, the whole area of how do we produce, you know, sustainable food in coming decades. So our challenge really in the coming few decades is growing more food and fibre while we reduce emissions and adapt to a changing climate. So we can certainly do it. And, you know, it's interesting that Victoria, the government does have a carbon neutral target by 2050. And so there's a lot of work that's already going into reducing emissions, and agriculture has been doing its bit. It's actually reduced emissions in the last 20 years. But there's just a lot more things that we're looking at what we can do to adapt to climate change as while we sort of start to reduce emissions. And we just released a little booklet recently which talked about some of the key areas and farms where we can start to, you know, reduce emissions. So energy, there's such a lot of work being done on renewable energies, and increasingly as some of those renewable energies get cheaper, a lot of farmers are looking at it saying, you know what, I'm actually can save money by putting in these different energy systems. So that's a really important area. Lots of trees, and you see lots of people are working on land care groups and farmers with their farm plans, trees and shelter belts. You know, having shade and shelter and vegetation on farms is really important. Having, you know, really healthy soils has been really important. There's a lot of work going on about how do we make sure we've got good ground cover on our soils and good healthy soils, which really acts like blotting paper. It can absorb more rainfall, and then it's there for the plants to grow more later on. Lots of work going on how we improve our livestock efficiency and how they, you know, reduce the emissions while we're still producing milk or wool or beef. And also nitrogen and some of those sort of elements of how do we find fertility on our soils. There's a lot of work on how we can do that. So all of these things, there's a lot more research and a lot of work happening, but all of them tend to have something which makes our farming more efficient as well as reducing emissions, so there's a lot of opportunities here, and we call them win-wins. So we've just got to work at how do we find the right ones that are suitable for Gippsland and get them adopted. And there's lots of good stuff happening with farmers and groups there now. And these are the sort of things we see, you know, across agriculture. There's lots of work happening with new technologies and research and improved genetics of crops and pastures, lots of innovations. And we've seen lots of farmers do lots of great stuff on their, you know, on-farm infrastructure, which is things like, you know, improved water storage or improved pipelines or improved fodder storage. And we've got, you know, lots of the world wanting to buy some of our food, but there's a lot of work happening on improving farm plans, land care. But the key bit is people working together, and there's some great groups in Gippsland that are working together to try and make agriculture better. So I hope that's been a good insight into, from the global issue of climate change, into all of the things we are and can be doing more of in your part of the world. So thanks, Amy. Making decisions today that leave us better off in future. That's the main aim we're after.